Hi, I'm William Malik, and I'm here with today's bit of security for May 9th, 2024. I'm going to talk a little bit more about the software bill of materials. But in order to frame that conversation, I'm going to begin with a little personal story. I've got a close friend who has food allergies. And so whenever we go out or whenever we make something with her and her friends and family, we have to take a close look at the ingredients. Now, in the past, I've told you that a software bill of materials is kind of like the ingredients label on a can of soup. Well, here's where it gets tricky. If you go to a restaurant or you bring stuff home, sometimes you'll have an ingredient like salad dressing, which itself is a mix of ingredients. And when you take a look at the list of ingredients in the salad dressing, it'll say spices. Now, that's enough for most of us, but the problem is that for this particular individual, there is a spice that happens to be a fairly powerful allergen. So what we need to do is we need to not just look at the bill of materials, but we need to go a second level and look at the bill of materials for the components of the supply chain entirely. This is particularly relevant when it comes to the manufacturing of advanced semiconductors. When a company decides they're going to custom make a high-end chip, say they want to do something special with artificial intelligence, and they've come up with a great design for such a chip, well, they don't want to just put it out there and have it created commercially, because that means the intellectual property, the secret sauce, becomes generally known and they don't have any competitive advantage. So what they do instead is they create a specific piece of software that encodes the algorithm that they want to see burned into the chip, and then they go to a fabricator, TSMC, for instance, that will build the chip to their specifications. So the company that wants the chip is going to go to a company that builds the chip. Now, what TSMC does is it takes that set of specifications and they put it into a tool. Now, just like the company doesn't own the fab doesn't own the tool. There's a company called ASML that actually builds the tool that allows you to inscribe the circuitry into the silicon chip. So the pattern, the model, goes in a form of software from the company to the fab, and then from the fab to the company that builds the tool. So we have 3 steps in the supply chain at least, and the company that builds the tool then has to interpret that properly so that it constructs the right fab. And these are very expensive processes. These machines cost hundreds of millions of dollars. Setting up a fab costs billions of dollars. Now, if you have a problem in a chip, if something doesn't work right, how do you diagnose it? How do you know where the defect was inserted? Was it a coding error by the designers of the chip? Was it an interpretive error by the fabrication facility? Was there a glitch in the process of the tool manufacturer? Or did something come along from somewhere else? A comprehensive software bill of materials has to include not just the ingredients, but the steps and pointers to the predecessor steps. It also needs to talk about things like what kind of environment, how was it tested, under what circumstances was it manufactured, what environments is it valid in. Software bill of materials is the key to unlocking the benefit of a rapid and highly productive supply chain. And without it, well, as they say in the fab business, if your yields are low, she's a no-go. Anyway, I hope that helps enlighten you a bit on the need for software bill of materials in complex manufacturing processes. I'm William Malik, and that's your bit of security. Be safe out there.